and do the opposite now, which is we'll have the Kp value and we'll try and find the concentration or solubility of the particular substance. I'm going to start off with the first one. Let's say I have the Kp value of NaCl, and the Kp value of NaCl is given as, so that's given as, let's say it's 1 point, these are hypothetical values, right? So it's 1.25 into 10 per minus 1 mole squared dm minus 6. And they're asking me to tell them what the concentration of NaCl is. So the Kp is given. Now I'm going to do the reverse. The reverse has to be done. First thing is I have to figure out the expression for Ksp for NaCl. Now NaCl, the first thing is I'm going to write down the equation for NaCl dissolving. Now NaCl solid mixed in water, so that's aqueous, and it's going to form Na plus 1 aqueous, plus it's going to form Cl minus 1 aqueous. So that's the equation, and the expression for Ksp is, in this case, is that it's going to be sodium ion concentration into Cl ion concentration. That's it. Into Cl ion concentration. That's it. And the value is given. The value of Ksp is given. It's already given as 1.25 times 10 per minus 1. So that's already with us. So that's given. So how do you find concentration? Now you don't know how much NaCl is actually dissolving, right? You don't know what the solubility is. So I'm going to assume that x mole per dm cube has dissolved, right? So that's an unknown, and my assumption is that x moles per dm cube has actually gone. That's actually gone into the solution. So you have got, so if x mole per dm cube dissolves, what amount of sodium ions are produced? X mole per dm cube. And what amount of Cl ions would be produced? That's also x mole per dm cube. ठीक है, is this clear, Sarah?
Okay. Yes. Yes. Yes, sir.
ठीक है, महफूज clear है? महफूज उस पर चैट पे टाइप कर लिया करो. अच्छा, so you've got an x mole per dm cube of Na plus 1 and x mole per dm cube of Cl minus 1. Now the thing is, I'm going to substitute these values over here. This goes over here. This goes in here. So it's going to become x mole per dm cube into x mole per dm cube. So that's x squared is equal to 1.25 times 10 power minus 1. So basically it's x squared. So you can write this as x squared, and x can be found by taking the under root. So you can take the under root of this thing. So I'm going to try and do that now. And that's going to give me my value. So just 1 second. How do we do this one? Can you take the under root of I've got it, 1.25 e minus 1, that gives me 0.353 or 0.354. Can you double check? Mole per decimeter cube. Sarah, did you try this on your calculator?
Yes, it's 0. Yes, it's correct. Got 0.354.
0.354, that's fine. So you found this is how you're going to find the value of if KSP is given. This is how you're going to find the concentration of the salt in solution. Now we're going to try and do another question now. Let's try a different salt. Let's say, for example, there's a this KSP for aluminum chloride that's given, or let's say aluminum nitrate is given. Now that's provided and it's given as it's probably very soluble. So let's take a higher value, 1.6 times 10 power minus 1. TK, the unit is mole 4 dm 12. Now that's your value. The KSP is given, it's provided. Uh, First thing is you write the expression for KSP. Before that, you have to write the equation for aluminum nitrate dissolving. So it's a solid. It's going to mix with water, aqueous, and it would form aluminum ions, 3 plus aqueous, plus NO3 minus 1, aqueous, and there would be 3 of them. So that is aluminum nitrate. That's the aluminum nitrate dissolving in water, and we're going to write the KSP value for this now. The expression for KSP. The expression for KSP is aluminum ion concentration and NO3 minus 1 concentration, and that's going to be cubed. Right? That's the expression for KSP in this case. Now we found the expression for KSP. Now the next part is you're going to assume that x we're going to assume that x mole per dm cube has dissolved. In a saturated solution, x mole per dm cube has dissolved. So that means the amount of aluminum ions in the solution would be x, and the amount of nitrate ions in the solution would be 3x. Because if one molecule dissolves, one aluminum ion is produced, and three times that much NO3 minus 1 ions would be produced. So in a saturated solution, if aluminum ions are x mole per dm cube, nitrate ions would be 3x mole per dm cube. And then the next part is you substitute these values in the expression over here. And if you do that, it's going to give you x times 3x, and that's going to be cubed. Yes, it's going to be cubed, and it's going to be 1.6 times 10 power minus 1, right? And you can then continues 3 cube is 27, so that's 27. X cube into x is x to the power 4. Try and solve this. It's 1.6 times 10 power minus 1. Get rid of the 27 as well from here. Put it over there. And the final thing is take under root of the entire thing. Not under root, the fourth root of this thing. And you're going to get your value. So can you try and do this? Mole per dm cube. So that's the value that we are going to get. 0.277 mole per decimeter cube. But you get the idea, right? How to solve these questions.
Yes, but I'm not sure with the units.
Nee, for
Centimeter.
x, I mean, for x is concentration, right? So concentration would always have a unit of mole per dm cube. I mean, you're assuming that x mole per dm cube dissolves, right? So x is concentration. So concentration will always have a unit of mole per dm cube. KSP always has different units. I mean, why does KSP have different units? Case because it's concentration multiplied by concentration cubed. So obviously you're going to get this thing. So is that clear?
Yes, sir.
I said try and do this question on your own. Send me the answer for this. So there's let's say there is aluminum carbonate, and the KSP for aluminum carbonate is provided. It's Al2CO3 thrice, and the KSP value is given as 1.2 times 10 power minus 5, and it's probably mole 5 dm minus 15. ठीक है, find the concentration of aluminum carbonate in a saturated solution. In a saturated solution, everything has to be exactly the same. And do another question as well. I mean, send me the answer to the first one. The second one is that the KSP for calcium bromide is given, and it's given as 9 times 10 power minus 2. And you have to find the same thing. Find the concentration in a saturated solution. That's so two questions. Send me the answer to the first one first. Of this. So there's a thing called common ion effect. Now, common ion effect is that solubility of a substance decreases due to the presence of a carbon ion. And I'll explain why. Due to a common ion. What that basically means is, and you can do the calculations quickly. Keep your calculator with you so that we can have a look, have a check. Uh, Now, I'll first explain the concept first. Now, AgCl, you're trying to dissolve AgCl. Now, AgCl is going to go into the solution, and let's say it forms a saturated solution. It's reversible only if it's a saturated solution. So it forms a saturated solution, Ag plus 1 aqueous is formed, and you have on the other side Cl minus 1, aqueous ions are formed. Now, the thing is that it's a reversible reaction. the reaction could go both in forward and in backward direction. So what if I decide that in this solution I add NaCl? Now, if I add NaCl aqueous to a solution in which AgCl is being dissolved, there's a common ion which is Cl minus 1 ion. Now, because of the presence of NaCl, Cl minus 1 concentration shoots up. Now, there's a lot more Cl ions because, I mean, this equilibrium is going to be affected. Why? The silver ion concentration, it's still low, but the Cl ion concentration all of a sudden it has gone up. Why has it gone up? Because you have added NaCl. Now, because of this much higher Cl minus 1 concentration, what would happen is that the equilibrium would shift backwards and less AgCl would dissolve because you have lots of Cl ions, and to counter the effect, uh, according to Lee-Chatelier principle, if you know what the Lee-Chatelier principle is, that if you try to increase Cl minus 1 concentration, the equilibrium would try to decrease Cl minus 1 concentration and the equilibrium shifts backwards. Sarah, is this clear?
Yes, sir.
So now here's a question, and that is, let's say I'm adding, or the solution has NaCl aqueous. Okay, let me write the question clearly. First thing, find the solubility in mole per dm cube of AgCl if it has a Ksp value of 2 times 10 power minus 5, right? So Sarah, can you quickly solve what is the concentration of ignore all of this for now. First, tell me what is the concentration of AgCl if there's just AgCl in the solution and there is no common ion, there's nothing else. I mean, you're going to assume that X mole per dm cube dissolves.
Is it 4.47 times 10 to the power negative 3?
So it's coming out to be 4.47
Times 10 to the power negative 3.
negative 3. Okay, you just took an under root of that, right? Sorry, you took under root of this, right?
Yes.
Achha, so it's 4.47 times 10 power minus 3. Now the next part is, what if we do the same thing, but now we're trying to dissolve AgCl, and I'm going to see the effect on the concentration of AgCl. Now we're going to try and dissolve it in, let's say, 0.15 mole per dm cube NaCl. Like there's already NaCl aqueous present. So we're now trying to dissolve AgCl in 0.15 mole per dm cube NaCl. Now now let's understand one thing, that what I mean, the amount of Cl ions coming from the dissolving of AgCl, that's very, very low. That's 0.004 mole per dm cube. That's almost negligible. So we can assume that that the amount of Cl ions in the solution is approximately equal to this. Like even if I add, there's already, I mean, let's assume that there is already, I mean, there's already 0.15 mole per dm cube Cl ions present in the solution. Right? I'm just trying to make a point right now. So let's assume that the solution already contains 0.15 mole per dm cube. You haven't even dissolved AgCl yet. And let's assume that the solubility of AgCl is not affected. So under normal circumstances, what amount of Cl ions are produced? It's 0.00447 mole per dm cube, right? If I dissolve AgCl under normal circumstances. Uh, so what do you think that the amount of Cl ions in the solution are mostly coming from NaCl, right? There are hardly any moles coming from the dissolving of AgCl. So how do you get this point?
Yes.
And the thing is that due to the presence of Cl minus 1 ions, I mean, there are already Cl ions present, the equilibrium has been shifted backwards. So the amount of Cl ions would be even lesser than this. So is that point clear?
When they shift backwards, it will be less.
Yes, because the Cl ions would combine with Ag plus 1 to form AgCl solid. Like you have,
Okay.
I mean, what you're doing is you've increased Cl ion concentration. Like your solution already has NaCl. So there's a lot of Cl ions already present. And the Cl ions, just 1 second. So coming back to this, my point was that the solution already. I'm going to draw a diagram as well to explain this more in detail. The solution already contains NaCl, a lot of NaCl, and it has a lot of Cl minus 1 aqueous already. Now, in the presence of Cl ions, this equilibrium would be shifted backwards. Sarah, do you get this point, right? The equilibrium would shift backwards.
Okay. Yes.
Just wait one. So the solubility of Cl ions would be much lesser. And AgCl is not going to dissolve that much. So the only thing that I was trying to explain right now was that in your solution, the concentration of Cl ion, this X over here, it's not unknown anymore. It's approximately equal to 0.15 mole per dm cube. TK, the amount of Cl ions is approximately equal to 0.15 mole per dm cube, and most of them are coming from NaCl. So in this equilibrium, most of the Cl ions are in the solution are not coming from the dissolving of AgCl. I mean, the amount of Cl ions that were coming from dissolving AgCl were already less. But since your solution already has 0.15 mole per dm cube NaCl, so most of the Cl ions are already present in the solution and their concentration is 0.15 mole per dm cube. So is this point clear?
Yes.
Now, silver ions, you don't know. So what you're going to do now is you're going to write the expression again. What was the expression for KSP of AgCl? It was silver ion.
Ag plus and Cl. Yes.
It's going to be 1 second. Try and solve this. So now it's 10 power minus 4 that's getting dissolved. So is this part clear?
Yes, sir.
And that's pretty much it. Okay, this probably sums up all of KSP. Remember that you'd be asked three types of questions. One would be to find KSP. The other one would be KSP would be given and you would be asked to find solubility. And the third one is that it's common ion effect. That if a solution already contains one of the ions that's going to be coming from the salt, then you do the same thing except that the common ion concentration is already coming from another salt. So its concentration is already very high in the solution. So you're going to take that as 0.15 mole per dm cube and use the same expression, do the same thing with X, except for the fact that this concentration would be taken as 0.15 mole per dm cube. And that would give you this particular value. Uh, so these are the three types of questions that you're going to get. We're going to do past paper questions. Most of the questions are going to be straightforward, except for a few that would ask things more creatively. I mean, they're going to ask you to do the same things, but slightly a bit more creatively. ठीक है, Sara? Is this clear? All three types of questions.
Yes.
So we're going to continue tomorrow then with past paper questions of this.
Okay, sir. Allah Hafiz.
Okay, take care. Allah Hafiz.